Okay, in this question, we know the probability is 1/5. We just don't know how many red and blue marbles there are. We've got to try and figure it out. We do, however, know that if you add 5 more red marbles, then the probability changes to a third. So one approach, and this is the way the mark scheme offers to do it, is you just go with it. So we know that if we had 1 red marble and 5 in total, then you'd get this 1/5. But if I then added 5 to both, then it would become 6/10, which is not 1/3. I can't cancel that down, so that's not going to work. Okay, let's try another method. So what about 2/10? That will also give me a probability of 1/5. If I add 5 to both, I get 7/15. That's also not 1/3. And we just keep going until we get there. 3/15 is 1/5. That becomes 8/20 if I add 5 reds. Yeah, because I'm adding 5 reds to 3 to give 8, but the total also goes up. Doesn't work. It's a bit unsatisfying, isn't it? Because you've got to keep, it's like trial and error. I'll show you another approach in a minute. That's also not 1/3. 5/25. Add 5 to both top and bottom of this. I get 10/30. Oh, that is 1/3. Actually, that is going to be the answer. So if I had 5 reds, and it would be 20 blues, because this is the total number, then that will work. If I add 5, another 5 reds, then the probability would change to a third. Okay, you might be happy with that. Fair enough, it does work. I'm going to show you another way. This is more complicated. It's an algebraic method, but it will guarantee the solution without trial and error. So let's call the number of red marbles R and the number of blue marbles B. Then I know that R divided by the total number, R plus B, is going to equal 1/5. I then know if I add 5 to that, so R plus 5, and I divide by the new total number, which is R plus 5 plus B, then I'm going to get 1/3. So the number of reds divided by the total number is 1/5. Number of reds plus now 5 divided by this new total number where I've added 5 is equal to 1/3, and I've created equations to solve. What I can do is I can multiply both sides by 5 and by R plus B, and this becomes 5R equals R plus B, this equation. And I can minus R from both sides, and I get 4R equals B, which gives me a nice relationship between B and R. And I've got four times as many blues as I have reds. Okay, you can do the same sort of thing here. I'm going to multiply through by 3 and by R plus 5 plus B. Okay, and you can see this method is more complicated algebraically, but there's if you're confident with it, then it will give the solution in a more robust and general way than this kind of approach, which we might have had to have kept going a lot longer. We just lucked out, really. It's a GCSE question, so they didn't make it go on for too long. Anyway, I'm going to keep going. So I can actually here replace B by 4R because they are the same thing. So I can multiply my bracket out. 3R plus 15 is going to equal R plus 5 plus 4R. And suddenly, I've solved a simultaneous equation here. I've now got an equation just involving R. So it's going to be 3R plus 15 is equal to 5R plus 5 minus 3R from both sides. 15 equals 2R plus 5 minus 5 from both sides. 10 equals 2R. And finally, divide 3 by 2. 5 is equal to R, which leads to that. And then we put that back into here. B is equal to 4R, and that's where we get 20 from. So, not sure which approach you'll prefer, but just make sure you are happy with at least one of them here.